welcome to another PD on Point. Today we're going to take a look at force and motion. We're going to directly look at 3.6b, demonstrate and observe how position motion can be changed by pushing or pulling objects to show work being done. We're also going to take a look at 5.6d, design an experiment that tests the effects of force on an object. Now, for today's lesson in force and motion, we've come to the science gym. But first, I'm not properly dressed for the gym. Give me 1 second. Now I'm ready. Let's take a look at some force and motion.
A force is a push, pull, or lift that acts on an object.
Friction is a force that results when two materials rub against each other.
A variable is an item or component that changes in an experiment, while a constant are items or components that do not change.
There are forces acting on us all the time, one of which is gravity. Gravity is a force that is pulling on all the objects in the world. Now we see that in gym class. Gravity is pulling down on us, and we have to push against it. One-handed. Not gonna happen. Now, in force and motion, we learned that an object will stay in one spot until a force acts upon it. We also learned that an object that is in motion will stay in motion until a force acts upon it.
The amount of force required to make an object move is directly related to the amount of mass. The more mass, the more force. The less mass, the less force. Every action has an equal and opposite reaction, much like a basketball bouncing off an object.
First try!
If every object continues to move until the force acts upon it, what force causes my cart to stop here in the gym? The answer is gravity and friction. Gravity is acting on all objects at all times, and friction with the floor slowed down the wheels.
Sire, there's a dragon at the gate.
A dragon?
Yes, a dragon.
A dragon.
A dragon.
Are you sure?
Yes, I'm sure it's a dragon. It's got a tail and wings and fire and everything.
So a dragon, you say?
Yes, sire, I do say, I believe it's a dragon.
A dragon.
Sire, what would you want us to do?
I shall seek counsel from the science jester. Science jester!
That's funny, that's what my mom calls me. Wait. Oh, really? I'm just a science guy. But in order to build this cannon today, we're going to use a ruler, styrofoam cup, some tape, and a marble. To the gates! So it's really a dragon? A dragon. A dragon. A dragon.
Here is how you set up your cannon. And here is our dragon. I place the dragon at the bottom of the ramp. Using a piece of tape, I'm going to mark the starting point. I'll measure the distance from the starting point to the fold of the paper at the end of every trial.
Here.
In the observations and data block, you can include a diagram of the lab. Ensure that there are labels in your diagram. Additionally, you want to include any form of data sets. This could include the data chart, as well as the data graph that's provided in the student resources. In the claim box, I'm claiming that there was a direct relation to the amount of force with the height placement of the marble. In the evidence box, I've included several vocabulary words that I want to include in my statement. Additionally, I can always add more vocabulary words via attempt or post it on the board. I'm using information gathered from the lab experiment to explain my claim. I'm also explaining which forms of force were present in the lab. I'm also including an explanation and identification of the variable in the lab, as well as components that were constant or the same throughout the lab. This is good practice for future investigations. Okay, now let's take a look at a STAR question. It reads, a student designs an experiment to test the effects of the width of the piece of elastic on the elastic's ability to stretch. The student selects 4 pieces of elastic with different widths but the same length. I'm going to make a notation here on the side of the different factors or variables. The student then attaches blocks with different masses to the pieces of elastic. The results of the student's experiment are shown below. In the margins, I'm writing a reminder to myself of the definition of what a variable is, items that change within my experiment. I also set in a reminder for myself of what makes a good experiment, and a good experiment has limited amount of variables. The less variables, the better. The question reads, what should the student do to improve this experiment? Letter A states that you use blocks of equal mass on the 4 pieces of elastic. That would leave me with the only variable of width. Letter B says to use blocks with enough mass to cause the 4 pieces of elastic to break. Now, why would we want it to break? The student wants to test the effects of the width of the piece of elastic and its ability to stretch. Letter C says use more than 4 pieces of elastic and 4 blocks. In this case, we will be adding variables when we want to be limiting them. Letter D states use 4 pieces of elastic with different lengths but the same width. Here we've changed the variables, but in all actuality, we've just swapped them. This keeps the original number of variables from the very beginning of this investigation. Again, we want to limit our variables. We're left with the answer of A that contains only one variable.